Hi, uh, I'm terribly sorry I cannot be there in person. So I have, just in case I cannot be there on time for my presentation, I'm going to try to be there at least for a couple of days. But here is my voiceover to comment on the slides for my paper. I will, if you can run this video, please, while scrolling through the slides together with me, then I can give you a little bit of commentary and you can run it in my absence. And then you can catch me in the corridors if you have any questions or comments. Again, thank you very much for having my paper, and sorry for not being there. Contents. So you will ask what's new in a vocabulary. We have been doing vocabulary for years. So I'll give you a few words to put you in a context and a little bit of background in how it all starts and the worldview and about systems engineering, so where it all came from. And then we will go through Wikification challenges. So I'm going to explain why we get to the point where we have the problem, and or say the challenge. And I will speak briefly about the problem entanglement, which is the complexity dimensions in the problem, this particular issue that we're facing, and how I'm going about it. I'm using a mixed method approach that integrates text extraction, classical text extraction, with a bit of procedural and organizational issues, and how this dimension can be integrated together. And I propose a little bit of an architecture for it. So what's new? I'm on the slide 3 or 4. I haven't numbered them, but it's the what's new slide. Shared vocabularies are not new, but it is surprising to find that in real world situations, not many people use them. So outside of the semantic web community and the knowledge engineering community, people, well, at most they call it nomenclature, and they say, okay, give me your definitions, but they don't seem to be aware, especially in my domain in systems engineering. And from what I've seen, the majority of people who are not born digital and who may not be ontology or semantic web specialists don't particularly have a clue, or they find it's a bit too tedious and pedantic to be worthy of any effort. And I joined the International Council for Systems Engineering in 2009, and this is when I started working on this. And this paper introduces the systems engineering, some of the challenges related to the systems engineering body of knowledge, in particular with an eye to the sociotechnical dimensions. And it introduces a new worldview and approach to this shared vocabulary issue. Systemic problems. You may have heard of wicked problems. You know, it's like there are technical issues that relate to semantic vocabularies, but I would say that these are trivial in comparison to the non-technical problems. And this is something we study in sociotechnical systems research. So these non-trivial problems are often inherently non-quantifiable, contain genuine uncertainties. These are how the wicked problems are characterized, or they say they cannot be causally modeled or simulated. They require a judgmental, a heuristic approach. And very often, a technically flawless system fails due to human and social factors, due to non-technical issues. So this is what we're looking at, the socio-systemic problem, which correspond to what has been called very often a wicked problem in the past. So if you look up the wicked problem literature, it will bring up a lot of issues that today we tackle as systemic problems. So I joined the Council for Systems Engineering, and I presented a paper in relation to knowledge, innovation, and some ontology thing. And Stephen, Art Peister from the Stevens Institute, invited me to join, to help them do this wiki move to the systems engineering body of knowledge to the wiki, which they were about to tackle with grace anticipation. And they said, well, if that's what you do, maybe you want to help there. And so this is how I got involved. And I found myself into a nice and very nice, interesting problem space. So I present, to start with, the worldview. Now, when we do mixed method research, which is something I've been forced to because there is no single method which can tackle my problem, when I start looking at the various facets, the various aspects of a problem space, I do not find a single method. I have to build a method. So complex problems or complex systems to some extent require an ad hoc methodology and approach. And very often this approach needs to draw from different methodological approaches to the point of becoming unstable. So when we mix research methods together, we need to make sure that we mix them in a way that they still stick, they still produce valid results. And the mixed method research, according to Creswell, which is one of the authors, revolves around a worldview. So the worldview is important, and Creswell distinguishes between four worldviews: post-positivism, constructivism, advocacy, and pragmatic. I have recognized that my work mostly falls under the pragmatic space. However, that what I do goes a step further. I insist that what we do, the worldview, so the approach and the paradigm, so to speak, that we take is that the work that we do is transformative, defined as delivering systemic change, and systemic in that it tackles issues as a whole and takes an integrated perspective. So this worldview characterizes a little bit, or attempts to be, the underlying justification for the way this work is done. Sociotechnical system. Next slide. So now you're looking at a diagram which has 3 or 4 bubbles. The 3 bubbles in the middle are technology, people, and processes, and the bubble in the outside is the environment. This is one way of looking at a socio-technical system. So while generally when we do vocabulary, we look at the technical problem space, at the technical challenges, in this research we look at the technological challenge as part of a people and process integrated challenge, and you will see why a bit later in the paper. So we are looking at the shared vocabulary from a socio-technical system viewpoint, and this slide shows you a little bit what how a socio-technical system can be defined. A few words of background on systems engineering. Systems engineering. So there is a whole body of knowledge which is several hundred pages. In fact, there are several manuals. There is the systems engineering, the INCOSE handbook, and a few other texts which can be considered as sources of knowledge. But in this sentence, which is taken from a paper published a few years ago, I think it summarizes the aspects of systems engineering that relate to what we do here. Here, the citation, which is in the paper, says that the discipline of systems engineering has been recognized for decades as essential to the development of complex systems. However, it is still treated primarily as a heuristics learned by each practitioner during the personal experimentation of a career. And blah, blah, blah. I'm not going to read it all, but let me read the last sentence. The differences in understanding, however, just as typically result in disagreement over the level and formality of the practices to include. Have you heard that before? I have heard that before. And it's in systems engineering, this is very obvious. It's a massive community practice, and each of them comes from a different, totally non-academic. Typically, I have met few systems engineers who have PhDs. In fact, I'm struggling to find a second examiner, as an external examiner for the thesis. And so the systems engineering practice, this is, I think, it is at a state where it will benefit from some level of semantic integration. Next slide shows the systems development life cycle, or at least one view on one representation of it. And it's just to remind you that systems engineering rests on the life cycle, which can be envisaged as a set of steps or development stages that you probably already familiar with. In the next slide, I show you how the life cycle phases, this is a little bit of work that I've done recently, which is not finished. So you will see that this table, I'm looking at a table on the slide called knowledge sharing. So what I do is that I map to each life cycle phase the knowledge and the documents that go with it. And then for each, I identify a typical format, narrative versus diagram versus structured text and or image. And then for each format, I will I note that there is a corresponding notation and formalism, and how this can be shared. What mechanism can be used for sharing, from image to Word document to more structured and more semantically enabled formats such as RDF and OWL. Okay, don't tell me it's not a format, whatever. Next slide. So what happened? It was people have realized that it would be good to have the body of knowledge, systems engineering body of knowledge, on Wiki. And that started posing a range of questions. First of all, we don't really have a systems engineering body of knowledge as such. We have a few handbooks, and then we have all these heuristics. So the wiki, in a way, it would be nice because it could try to capture these heuristics. But how do you start? How do you go about it? So there's been meetings and WebExes and calls between different people. And now this is kind of started to happen now. There is a plan, and it's started to happen. Although it's not a semantic wiki yet, it's just a media wiki with the idea of using a semantic media wiki later on. So let's look at the Wikification process. So the first problem that we had with Wikification is to sell it to the community, because a few systems engineers are already sold to the wikis. In fact, they just can't wait to get on it. But I don't think we have a survey, but we have a lot of people who have not at all familiar with it, or haven't heard of it, or they think it's something a bit too new for them. So it's the first shift is obviously a mentality one. It reflects the logic of a technical system being implemented. So basically, we have a range of issues that goes to Wikification, not just the, what vocabulary do we use. And I'm going to show you in the next slide what these issues are, in the next few slides what these issues are. So the practical challenge to Wikification is, how do we go about it? How do we migrate the content from books and handbooks and PDFs into a wiki environment initially, and then into semantic media wiki environment? What kind of structure should the wiki provide? What model of governance is suitable for a distributed multi-authors team that would allow both maximum flexibility to encourage contributions, and that would also support sufficient validation for the quality of the contribution? These were the Wikification challenges, which are typical to many domains, not just the systems engineering. Systems engineering has a few more. I have a few peculiarities of their own, but I haven't identified them here. So this is where I think this paper or this research frames the problem in an interesting, unique way. I call this entanglement or circularity. There's probably also, we could call it recursiveness to some extent, but so I'm looking at the slide. It says entanglement, circularity. So loading the corpus to a wiki requires some decisions in relation to the structure, which means how to best organize the corpus depends on how the corpus structure is defined. And subsequent ongoing edits and editorial changes to the body of knowledge after it has been opened up on the wiki will be determined by what editorial process is in place. And the editorial process in turn depends on what governance model is chosen. So these interdependencies, we call them entanglement. And one possible way to solve this entanglement is identifying the mapping of all the key factors and the interdependencies, and constructing a project schedule and a plan that works with them. So essentially, we are trying to follow an agile approach to developing a vocabulary. So I define in this work entanglement in two ways. One is we look at the knowledge sharing as a problem made up of different problem spaces, such as technical, cognitive, organization. So we are saying knowledge sharing is not just a matter of artifacts or technical artifacts, but is also a matter of cognitive psychological learning challenges, so pedagogical issues, as well as the organizational and policy issues. So the processes, how do we go about it? So we cannot say that knowledge sharing is only made of one of them. In order to get to grips with the knowledge sharing challenges, we need to look at the problem as a whole. And the next type of entanglement, so this would be entanglement 2, next slide. Next entanglement looks at the interdependence of governance, structure, and processes, which I described in the earlier slide. So they depend on each other. Which structure we take depends on what process we follow, which depends on what governance model we have. Nice. So I hope you like complexities. I hope you're not afraid of complex stuff. So how do we go about it? We follow a mixed approach. So we look at different ways, we look at different methods, and we pull them all together. The first method, which is documented in a paper or in a draft paper, which is linked at the bottom of this slide. So I'm now looking at a slide called Automated Text Extraction Approach. And this is a very, very summarized slide. It was initially 8, and then it became 3, and now it's 1. But basically, in the link below, you will be able to read a detailed description of what I've done here. And I've simply taken, I was trying to convince the community. What they had done initially is that they've asked the body of knowledge editors, which is divided in chapters, to each come up with a set of definitions at the end of each chapter, say, make your glossary. And typically a chapter would have between 5 to 7 or 6 definitions, which were, I would say, arbitrarily chosen by the author, saying this definition, and they would define it according to obviously their definition, but also they would define the words that they would consider important. So what we have done here, which was within my skills, because I'm not really that good with tools, I haven't got around to use TopBraid and Refine yet, because I need to download them. I like to use web-based tools. So I went into OpenCalais, for example, and what I did is that I picked a chapter, I scraped it from a PDF and dumped it on OpenCalais, and I looked at what kind of text analysis would come up. And we have tried 2 or 3 different tools, which are listed in the paper. I think OpenCalais and Alchemy were the 2 that produced some reasonably interesting output. But consistently, the result was that an automatic text extraction tool will be much more detailed and granular into the type and number of terms it extracts from a document of keywords in comparison to the manual one. So the suggestion, and also it was capable of structuring them, although the tools that we've used were not specialized tools, were not trained for the systems engineering domain, which is something we presume we need. It's a gap that we could possibly aim to fill as part of this work if we get that far with it. And the recommendations were, editors, look at the output of these text extraction tools and check your glossary and see, how it stacks. And also we realized that there was no categories, so the authors manually listed the terms, but they didn't cluster them, they didn't categorize them. So this is, and while the automatic text tool would do that, even if the categories were not representative for the domain, we're obviously starting to say this is an entity versus something else. And we've seen how these categories could also serve as metadata and could be used to be translated to support different schemas such as scores. So if you're interested in how the automatic text extraction, what it yielded, there are some dumps in the paper listed below. Next slide. Another approach is the morphological analysis, which sounds like a very big word. What I did is that I was searching for methods to formally analyze sociotechnical systems. I say, what methods exist to do formal analysis of a sociotechnical system? And one of the tools that I found one of the systems that I found. It's called morphological analysis, which I don't know whether it was invented by Professor Zwicky, but it was definitely codified in some way. He was the first one who wrote papers and structured it, used it in a formal way. I have another presentation that explains or tries to explain what morphological analysis is. Let me know if you want it. It's online somewhere, and I probably not the best because I had to get the information from other people, so it's not first-hand information. But morphological analysis is interesting because it looks at the it is used when a complex issue is not well formulated. So next slide, what is morphological analysis used for? Complex issues which are not well formulated or defined. So we're looking at the wicked problem or the systemic problem again. Or well-formulated defined issues with no single solution, so different solution depending on different factors, or well-defined problems with specific solution which needs to be worked out. Very often in morphologists, they use the word mess as a technical term to define a complex problem. You know, it's a mess is it's a word used in this field to define a complex problem. So if someone says your project is a mess, it's not meant to be offensive. It's just meant to be, it has all the characteristics of the wicked problem, which is a nice thing. So next slide, I'll show you my morphological box. Earlier I showed you the diagram with the cognitive organization of technical entanglement. So this is how the morphological field is detangled. So we look at various, and this is a little bit arbitrary what you put in these boxes. This is how you figure things out. And then I'm still coming to terms. I haven't completely finished my morphological analysis, so this is the first half of it. It needs a bit more cross-referencing and a little bit more exploration of all the combination of the fields, which can be time-consuming, and I'm going to try to do this later this year. So, and now looking at the three issues which I think are fundamental to the knowledge sharing problem, I'm on the slides called process. I'm going to go through three different sets of questions and show you how each of them, how we are going about solving each of them, and then we finish by looking at how they all stack together. So in the slide called process, the question is, what's the best way to migrate content from a hard-coded document to a wiki or a semantic media wiki environment, and then to maintain future updates? So you will appreciate that there is no straight answer. This is, you have to work it out. And just to simplify this, this is broken down, the solution is broken down into, okay, we can either upload the working version of the body of knowledge, so make a document and then upload it, and then it's a single step or a series of steps, for example, one chapter at a time, and this will be done by a bunch of editors or dedicated team members, or the other approach, and probably there are others, so these are the two that I identified at the spectrum of possibilities, to allow users to make ongoing edits and changes throughout the life. So basically, you don't upload a document, you assign the editing privilege to a team of editors, and you let them upload their content in their own, according to, individually, and then look at so that will be the way of looking at the emergence. As you can see, it will capture emergence. The second formula. In our description, a process consists of a series of dynamic steps. So it's not a model, which is a static representation. And the following processes are required to deploy a body of knowledge to a wiki. And for example, we are looking at editorial process. For example, first you do the creative, the concept, and then you do the production, and then you do the publishing, for example. So creation, production, and publishing are three possible steps in an editorial process. And this is something that all the authors would take part into. So again, we are looking at the process, governance, and structure entanglement, and we're trying to see how could we solve just the process. And I suggest that there are at least two ways in this slide. In the next slide, we look at the structure. Question is, what kind of content structure should the wiki provide to enable meaningful representation of the content? And here I find it necessary to define what we mean by structures, because again, in these many meetings we've had with different people, structure is often perceived as the table of content. So the structure of the body of knowledge would be the number of chapters and their titles and sub chapters. Whilst when we refer to semantic structure, we are referring to the values and properties and the relations, and so it's a different kind of structure, semantic structure, and it's worth distinguishing because to do this job we need both. Governance. The next slide called governance. A governance model is who does what, possibly also when, how, and why, I often say, but who does what, just to simplify. So the characteristic of a technological environment influence and shape directly the governance model. So the governance model, called GM, the governance model required for a large distributed project would necessarily have to take into account the virtual and distributed nature of the team. So you see how a governance model needs to reflect the technological environment. And I think there is a much bigger discussion and a much more interesting one than I can get to in these 20 minutes. I probably over. What tasks constitute the editorial process? What roles? What sequence priorities rules? So these are 3 examples of governance issues, and we need to make all of them firm, or at least some of them, or even more of them firm, before we can tackle the governance issue. So you can see how each of these different dimensions has its own internal logical structure. It's a different set of problems. So how do we bring all these problems together? I have learned from integrating taxonomies, looking at the work of Denise Bedford, who I had the fortune to meet briefly once at the World Bank. She has explained it very well, and I think this diagram summarizes. So basically, you keep the original structure of each dimension, you just make sure that they interface at some level by a central structure which can handle them all. Finally, this is more or less the last slide, the proposed architecture outline. So what I'm saying is, we should have a metadata, let's call it a vocabulary architecture, but considering that many of these vocabulary terms will be also metadata. We look at, on a first dimension, we look at structure. So the structure is created by assigning tags, and this can be done both as folksonomy or as a top-down taxonomy. So the taxonomy integration is also something that is explained in literature quite well. And at this stage, we're not distinguishing between the two. We're just saying content structure is created by tagging the terms. And the second dimension is governance. And we're saying it should be how this structure is created should be closely designed to match how the people create the content. So, for example, an author, and I say use case because we have different types of users, okay? In our use case, I'm now looking at the proposed architecture outline, and the first bubble says use case, and that is assuming we have authors or editors or other types of users. In the case of the author, say, or the editor, there will be a corresponding credential, so a way of identifying this person and a role that they come with. And each role obviously has permissions, right? So we need to build these information of who the user is, what their credentials are, and roles and permission are, and somehow match it to their ability to create or modify the content structure, so the tags. And finally, um, a process. So for example, the editorial process, which say will be publishing, creating or editing, or what was it, creation, production, and publishing that we said earlier was as an example of editorial process, should also be broken down into tasks and integrated into the workflow. So at this stage, we have a person who is a user, who has credentials, role, and permissions, who follows a process, which is a set process, say an editorial process, and the structure is created following their process. So depending on what stage in their editorial process, for example, this user is, how the tags are created or modified or associated with the content, and this will generate some structure. I'm pleased to say that this is still a proposed architecture, in the sense that it is not yet implemented. The purpose of this paper was precisely to present this and to verify to what extent it's valid, and to check what people have to say about it. Next slide. So say how you're going to go to see whether this, what you're doing, is going to be of any value. And just a simple text extraction, text extraction, vocabulary extraction, can be evaluated against a gold standard, which is comparing the automatically extracted text to the manual glossary. And this is something that I am doing. However, in our case, the manual glossary is not the gold standard at all. So there is no gold standard in our case, and so we can, the gold standard with a pinch of salt. We'll have to do something about that. More importantly, we may have to devise a set of competence questions that answer all of those issues outlined earlier. The process, what was it? The process, structure, and governance issues, for example. In the next slide, I will show a few examples of competence questions, which is, I think it can be called a heuristic evaluation, which is, in the absence of anything else, we'll have to devise some, say, does the vocabulary do that? And then if it does, then we can consider it valid. And we will have to integrate these various evaluation methods. And most importantly, I insist on looking at cost, or how efficient it is, because we need to make sure that what we're doing is not only technically or satisfactorily from the technical or socio-technical viewpoint, but also can we afford to follow this method, or how can we do so with the minimum amount of resources. So the next slide, and this is definitely one of the few, I'm sorry I'm slightly over. So coverage, scope, specificity, structure, maintenance, and usability. This is some examples of some competence questions that can be used to evaluate vocabulary. I need to refine these competence questions to include the other aspects, which are governance and other issues in here. So these issues are covered only in part by this example of competence questions. Conclusions. We got to the end. This paper presents a socio-technical view of the challenges associated with developing and implementing and managing a shared vocabulary for systems engineering body of knowledge. So as you can see, we go a little bit beyond of what you may have seen in standard vocabulary extraction before, and it analyzes various aspects of the problem space using innovative worldview and integrating barrier analysis and knowledge presentation techniques, proposes an integrated emergent architecture to combine vocabulary creation and management with other aspects of the Wikification task, including synchronizing the vocabulary development to the structuring of the body of knowledge and the governance of the editorial process. Future work. So now the team is moving to a wiki, but not a semantic media wiki yet. It's going to be quite a riot as it is. And some of this work will hopefully help to produce a semantic media wiki for the systems engineering body of knowledge in the future. And at the moment, the proposed architecture is a concept really, and so it's intended as a guidance and as a discussion. So we will have to work on that before we. I mean, I wouldn't say we can just adopt it as it is. It's a starting point. I had to bring all these ideas together and present them consistently, and I hope this paper does that. A fully fledged text extraction exercise could result in a gazetteer. So one of the guys at Loughborough, who's doing something for a subset of the systems engineering body of knowledge, he said, oh, I couldn't use Gate because it didn't do the job when it parsed and he said, okay, it didn't do the job Gate because we don't have a gazetteer for systems engineering domain. Maybe we could do it. So we thought we should do this sometime in the future. Last slide. The last slide is this elephant with the is not anymore just blind men who can get a part, but it's they can each link and connect to other parts so that they can get the whole picture, hopefully. I must thank the EPRSC for a doctoral training account and University of Strathclyde for assigning me the scholarship and the freedom to do whatever work I see fit. Nobody's helping me out or telling me what to do, which is both good and bad. And thank you very much. My email address in the last slide. I'm really sorry again for not being there, but at least you got a minimal talk. And I want to thank you for listening. Please get in touch, and I will try to get there as soon as I can. I'll speak to you later. I hope you're having a great time. Thank you. Bye.